Yo, what's up guys? So this is the actual development video where I'll be showing you how to find the evidence that Minecraft now has 6 block reach. And the other videos were just to demonstrate it. This is for those of you who are explorers and want to see the actual thing where I found it and don't want to watch all those long videos or anything like that, or the long video or either the two flashy videos. So I will not be having any Minecraft content in this video. Well, I might demonstrate the actual bug concept in this video, but I'm just gonna be showing you guys how to set everything up, and it's really easy. So we're just gonna be going over to Chrome here because, like I said in the last video, Fabric does in fact give you a way to get a mod environment where you can actually decompile the game. So this is for people that are learning or want to see the actual exploit concept. I'll put a time signature on screen so you can see when I'll actually show where the code is. You can see here you just want to go to fabricmc.net, and this is where you'll find everything that you want to get. I'm going to be doing develop a mod, and there's going to be a way to get a template here. As you can see, it's example mod repository. There's also an online template mod generator. That's what you want to click on because it's just a little bit better. It lets you put anything in here you want. So I'm going to call this exploring because this is going to be our mod just for specifically exploring. There's going to be really no reason to be doing this other than to look at the game. And we'll leave the packages combat example because we really don't care right now. And I'm not going to add Kotlin or anything like that. And if any of you guys don't have IntelliJ, you will want to get IntelliJ. Now, if you're on Linux like me, you'll have to go and extract what you download and actually go into the bin and open the IDEA executable. Either way, whatever platform you're on, you'll just download and basically install it from there. So I'm going to be showing that now. So here's the mod template. I'm going to be putting this on my desktop. And then I'm also... Okay. Watch that reset the next time I restart. So now I'm going to be going into IDEA, and you can see here I got to go in here to bin. I'm going to be opening the IDEA executable from there. Yes, I don't have any shortcuts. I never do anything like that. I don't care. I don't do path stuff. I don't care about IDEA anyway, so path would be the last thing you would do. So once you're in here into IntelliJ IDEA, if you don't know what you're doing, again, that's what this part is for. You'll want to essentially open the project. So what I'm going to be doing is I'm going to be putting the template in here, and I'm going to be extracting it. I'm going to delete the original, and I'm just going to navigate to this now on my projects drive here. I'm going to refresh. I'm going to refresh again. I'm going to refresh again. I'm going to refresh my entire home. Okay, I had to refresh a folder. Inside of the folder I wanted to refresh to actually get it to refresh. Interesting, IntelliJ IDEA. Again, that's not the point of this. That's not what we're doing. We're just trying to exploit, right guys? So, we're going to head in here now. And I'm going to go over to my example mod. Little introductory that's given me here. I'm just going to space my way out. Let's set up a JDK. I have a few. And now you're going to want to go to the few positions I'm going to give you in the description if you want to see this for yourself. And so what I'm going to do is I'm actually going to read the audit the AI gave me to do this. Now, of course, again, there's a few things that we're going to want to find here, but what I'm going to do is I'm going to go on my own behalf to these folders that the AI has decompiled the game with, because as you can see, these are .javas, and this is the actual decompiled game. When you're working with a Fabric environment like this, the game is not actually decompiled. IntelliJ will decompile it. It's just acting as a library. We'll still be able to see the code because IntelliJ will dynamically decompile. However, the AI used the CFR decompiler, not IntelliJ. We're going to go in here to where it says to go. So we're going to open each of these up. Essentially, first we're going to go to Net Minecraft Server Network, okay, and Server Game Packet Listener Implementation. And you can see I already have this open. It's set to go to line 1770 for this file. And this is what you can see it says here. But now we're going to go into it in the actual code. So what you guys will want to do is, again, go to this location in the description. I'm sorry, it's not com, it's net.minecraft. And of course, again, this will be the same for all of you. If you're working on Minecraft 26.2, you basically are just navigating into Minecraft's code itself right now. So again, we're just going to server.network. Okay, and then we're going to type in server with a capital S. Game packet listener impl. This is now the place we're going to go to. So you can either right click this and do go to declaration of usages, or you can see here it just says control B. So I can do control B while clicking on this, or while having my typing indicator on it. Then I'm going to basically just look at what this is. So I'm going to copy this. This seems to be pretty relevant code. It is within attack range. So I'm going to search for this within my actual IntelliJ decompiled game code here. And you can see this is the same code that it's showing here, or rather, it's a slightly different order because you can see here it just does the opposite and then it returns. But this is the same code because you can see that this is the same condition. Okay, so it does AABB item stack is within attack range 3.0. AAB item stack is within attack range, and double 3.0f, or f is float, of course, it's just casting it to double for whatever reason, but we're going to ignore that. Again, this is a decompiled game, right? So these two are going to be a little bit different. So now what we're going to do is we're just simply going to go in here. We're going to do Control B again, because it's going to tell us to go here in a second anyway, and I'll show you that, because it tells us to go to net Minecraft world entity player.java. Okay, it says is within attack range, and that's where we are right now. Now this line again is not quite exactly the same. Actually, oh, this one is the same. Funnily enough, it says 1891, so this one actually is the same. 1891. You can see this is the same code. So I didn't even have to go there in the files here in the decompiled game that the AI made, because I just have it right here. Right? Okay. So then it's going to tell us to go to the same thing in attack range, and I'll show you that. This is the attack range function. So this is a function on the same class. This is the player class. This dot, meaning we're talking about the player. But then it's going to call another thing is in range on that, and I'll prove that to you. Because here we are in attack range now. And if we go down to where this AI is talking about, it's going to be going to this function. But this function calls this one, because so does this one. These two are overloads of the same function. This is the actual full body here, right? This just does a null check, and then it casts some stuff, and it gives it a certain predicate. These are two different predicates, or rather delegates or something or other. Anyhow, the point is it'll call this one down here. It's just another version of the same function. And the AI is going to tell us that exactly, and I'll show that to you. That I will prove to you, because this is the file right here. This is attack range.java, and again, you can see I have it open here in net Minecraft world item component, but you guys want to do this, because again, you can just do Control B once you get to the first class. And then it's going to show this code here, and it's going to say, essentially, here's what the AI is saying. It's saying to go to line 92 to 101, and if we go to 92, we see this is the function here that I guess is called by player, and if we go to 101, it goes all the way down here to this one. So the AI is telling us to select all of these, and oh look at that, that's two functions. And as we can see here in IntelliJ, because it highlights the correct functions, this one actually calls this one down here. So now we can go to the right here. We see a couple of functions we can investigate, and I'll investigate these with you guys here today now. So this function is in range. Essentially, it's going to determine whether the entity you're attacking is in range on the server side. How do I know this? Because it's being called by the server networker. So you can see on net Minecraft server networking, this is in the networking package on the server package, meaning this is going to run only on the server, and it's going to call player code, and this is server side player code. The way you know is because there's no checking to do with anything client side, and this is just relegates to other functions being called by a server function. And then you go here to the attack range, and you see, well, again, this is just math. So this is all being done on the server side, guys. So where does this math come from then? We'll see these numbers that it's using here to calculate these math equations, this little function here, right? This formula, you might put it. We're going to go to the function it's calling here. So you can see here we have effective max range and effective min range. Well, these two functions are just right up here. You see here when I click on one of them, it highlights it down here. And vice versa, it highlights them up here when I click on one down here. And so let's look at what this code is exactly doing. Well, what we see is it's calling on the attacker to get the attack range that they have, the effective max range and the effective min range. We'll figure out what these are calculating here in a second. Then it's going to add it to the hitbox margin, which the AI tells us is 0. I'll prove to you that's the case here in a second. The AI is right. Then it's going to add the extra buffer. And if you recall, if we go back to player, extra buffer is the third parameter. Let's see, let's look. The third parameter here in is in range is, again, final double buffer. And if we go back to the packet handler, it's 3.0f. Now, if we go back to attack range, what we'll see here is that it's adding something to 3. Well, let's figure out what these things are. And don't worry about the min range, because as you can see here, what it'll end up doing is it'll basically just take the negative, and it'll say if the distance is essentially lower than the max and higher than the min, and the min is the -1. So you'd think it would be -3, so behind the player, and 3 in front of the player, right? Well, it'll end up being something like that. So let's just see here if we look at extra buffer, right? Again, we already know that's 3. Let's look at hitbox margin. You see here, that just like the max reach, min reach, and mob factor values here, and max creative reach are, and the min creative reach are all values up here in the attack range record. So let's see, and you can see here it says no usages. We know that's not true. The game doesn't just not use this. That'd be ridiculous. And that's true. But what I'll show you guys is we'll actually search through the code base. Since the AI has decompiled these sources for me here, I can open those up in Visual Studio Code and search them. Again, you guys will be able to do the same thing. I'm just going to show you how I found them because I have all the code here, and I can map them out to what I can find in IntelliJ. It's just since IntelliJ is decompiling the game one source file at a time, it doesn't have all the information to be able to know things like references, so I can't actually browse the code like that. So for things like symbol browsing, I'll have to instead opt for a pure in-file search. Okay? That's exactly what we're going to do now. We're going to do a file content search. So essentially what I'm going to do, okay, let's just search for attack range. Okay? You see here actually we see a new attack range. And it's funny, it says the min reach is 0, the min creative reach is 0. And then the max reach and the max creative reach are interaction range. And it gets interaction range from the attribute of living entity. But we'll get back to that here in a second, because the AI, if you recall, says something about entity interaction range. We'll show you that here in a second. But right now we're focusing on this attack range. Where do we get all these values from? Well, let's search for attack range. And when we do so, what we get, let's let us search here. Is only 87 results. And it's funny because none of these are constructions. Because if you notice, we had one. If I look for a construction of attack range, we only get 2, actually. Well, this is a very, very specific one. Don't worry about this. This essentially never gets used. Okay? As you can see, this is on specific information about a spear, it looks like. This one here is the only other one in this default for. Well, let's see where default for gets used. If we search for default for, all we find is get attack range with, and then an item. And we saw that the only item that's ever overrode is spears. Otherwise, it's going to get the attack range of the item, which is just the default. Okay, and then it's going to do the default attack range, right? So again, if we have a weapon and we'll say it's a spear, it's going to have an overridden attack range. We saw the only other overridden attack range was spears. If that's null, well, it's going to use default for this living entity, of course. But we can find that once we go back to default for. Here's the living entity. It gets the attribute entity interaction range. Well, let's look for that. It's entity interaction range. What we'll see is something pretty baffling. There's also not many occurrences of this in the code as well. You'll see here, the only thing we see here is creative attack range, which is 2. And I guess it's going to add 2, right, to what you normally have. And then a 0.5 for blocks, which is kind of weird. Let's not worry about that. Then we see we're getting the attribute, you know, updating some stuff. We're not changing anything. This is still to do with creative. Okay. Then we see we're adding the entity attack range to what? Create living attributes. We're going to see this here again in a second. And I showed this in my last video that I found. We're going to see this again here in a second. Let's actually open this tab. Just leave it here. Now we're going to see entity attack range. This is in the attributes class. And that the default is 3. And the max is 64. That's all we see here. Let's keep this tab open too. We see this is just more in the same line of code. We're going to keep going. We find player, default entity, interaction range. This is never used. This is a constant that's generated by the decompiler. But we are going to see a 3.0 in here, so we're going to pin this tab open too. Then we have attack range, where we just were. Well, okay. Let's see what this value gets used for then. So all these are 0, 0, 0 hitbox margin minimum, and then 1 mob factor. Well, what's mob factor? Let's look at what is that again. Let's just see. Let's check it out. Oh, it multiplies. So it does nothing when you multiply by 1. Min reach is 0. max reach is 3. You can't hit behind yourself. That checks out. But other than that, it's 3 plus hitbox margin, which we know is 0. Plus 3. Because we know this third parameter in this function is the floating point value of 3. Then it's going to check if the distance of this attack was less than 6. Don't believe me? Let's prove it real quick. Let's go back to what we were seeing here. Here you can see entity interaction range says a default of 3. So wherever this is used by default, it's going to be 3. Well, here we remember that there was a default value. Let's see where this is used. What happens if I copy this and then I search for it in player? Look at that. Create attributes has create living attributes from living entity dot add block interaction range, because players need a block interaction range. Other than that, doesn't seem to do anything to it. Let's look for 3.0 here. Or rather, we're gonna look for it in, it might be local player, however, it might be just in here. Ignore that. I don't know. Wait a minute. Might also be in server player. Look, I don't know. Anyhow, I remember seeing another 3.0. That also doesn't matter. You just saw that the reach is actually 6 on the server side. So, again, remember, if you guys want to see this yourself, you just have to set up a fabric mod. You have to do the same thing that I just did. And you can see it for yourself. You'll see all the same things. Oh, here's another instance of that, where it sends 3 to this function, which adds it to entity interaction range. Entity interaction range return this dot get attribute value for the player. So this is just general interaction range is actually 6 now, not just combat reach and things of that nature. So, hope you guys enjoyed this video. I hope you guys got something out of it, and I will catch you in the next one. Peace.
Okay, I'm gonna go. Do record this, okay? Shut up, okay? Shut up.
Sure, dude.
Did they ever tell you to seek out your dreams, to find purpose and to find use? No, you better watch out what they say to you, 'cause it might not always be right, no.